Hey everybody, day 37, Grandma Math, Twizzlers, pull and peel math, from simple shapes to geometry. Simple shapes. Here are some simple shapes: triangle, square, circle, rectangle. How did they make these simple shapes, and what will help us make other simple shapes? Well, we need to learn about points, lines, and angles. Let's go. Grandpa found Grandma a bag of Twizzlers just like this one. So you're going to open it up and pull out one band. Just like that. Cherry flavor will be fine. Open it and pull one out. You can get any flavor you want, but I think they only really make cherry. It comes in a cable with 9 strands. Peel off one strand, but don't eat it. That'll be tricky. I didn't know that they came with 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 9 strands. And I'm going to take off 1. Oops, it broke. I may have to eat that one, but I think it'll still work. There's 1 of 9. Hey, we just did fractions with the apples the other day. Pull and peels are made of fractions, and odd ones. 9 is an odd number. I have 1/9 of the braid of pull and peels. There's my broken part. That'll tide me over now. We will use it later as an example of a straight line. Okay. A plane. Grandma's tray is a plane. It's a flat surface. We need a plane to put the points, the lines and the angles. We need a plane. No, not an airplane. In math, a plane is a flat or level surface. Pretend this page is not a sheet of paper. We'll imagine it's a level plane. Point. Now draw a dot. Grandma's going to use the Skittles as my dot. Here's one dot. Here's the second, our point. Here's one point. Here's the second point. So they drew a point here. And then they drew a point down here. We will call it a point in space. This point is not in outer space. It's on our level plane. Then we will draw another point. 2 points. And notice I put mine so they can be drawn, make a straight line between them. A line. Now it's time to make a straight line. Here's a strand of Twizzlers, pull and peel candy, between the 2 lines. That is called a line segment. I put my Twizzler between my 2 points. Now, my points are connected with a line segment. This line has a start and a stop. So it's called a line segment. Here are more lines. If I start my point and it has an arrow on this end, we call it a ray. An array goes on forever because I'm not stopping it. I'm saying if I could, I would go that way for a long time because it has an arrow on the end. That's a ray. And I can make it go any way I wanted to. Go over this way or down that way in my straight line. Doesn't matter which way the ray goes. A line that goes forever in both directions. So I'm going to take away my start dot. If I put an arrow on each end, I would say that the ray goes on either way, and now it's a line. A ray has a start point and goes one direction. A line can go both ways, forever, if we could. When two lines are on the same plane and they cross each other, they make a point. So I guess I need another one. I'm going to try not to break this one. This is why pull and peels are fun. All right, I'm going to make these two cross, and this is the point they cross. I had a start point on the first line, and then it was a line segment. But where they cross, that point is the intersection. Pretty cool. Angle. An angle is a bend. Usually we talk about it as the corner, as a bend or an angle. Now, let's draw some angles. Where two rays meet at a common point, they form an angle. Here are my two rays. I have a start point, but no end. So it's not a line segment. Now, it's an angle. An obtuse angle is a wide angle. So if I make it really wide, that's an obtuse angle. And if it's a really small angle, so the V there is really small instead of really wide, it's an acute angle. It's so cute. It's a cute angle because it's small. And here we go back. Oops, Grandpa's going to need another one. So I could have left my other angles out like in the book. And then I could have my very wide angle, the obtuse angle, versus the acute one. And here is just a line. A line does not have an angle in it. Parallels. Two straight lines that lie in the same plane and do not touch are called parallel lines. It looks like railroad tracks. Railroad tracks do not meet. They go next to each other in continuous straight lines. Railroad tracks look like lines. When we put the segments together, they make straight lines. A road will do that. It's parallel. I have a road going one way, road going the other way. My pull and peels get some kinks in them. But you get the idea. Use your imagination to think of other parallel lines. How about train tracks? How about the lined paper in your notebook? Or the lines on a football field? Right angles. A right angle has very straight lines. One is horizontal and one is vertical. When they are straight up and down in the corner, that makes a right angle. That's what happens to make those squares or rectangles. Remember the simple shapes at the beginning of this book? Now you know that parallel lines and right angles can make a square. A square is a four-sided shape. It has four line segments of equal length and four right angles. The opposite sides of the square are parallel. So when I use my pull and peel Twilzzlers, which are the same size, when I put four of them together, I make a square with four right angles and four line segments. I can also make a rectangle if I pull out some more of them and make one side too long. Perpendicular. These lines are now perpendicular. One is horizontal and one is vertical. Then two lines are at 90-degree angles. They're also called perpendicular to each other. Look around. Can you find perpendicular lines in your neighborhood? Perpendicular is a good word to know for a spelling bee. Perpendicular lines. One line is horizontal, one line is vertical. And where they meet, look at the top of fence posts. You get perpendicular lines. A rectangle. 90-degree angles, but one side is longer and two sides are shorter. So if I took one of my Twilzzlers and cut it in half, I could make a rectangle with two equal short sides and two equal long sides with the right angles. And where these touch each time, we make perpendiculars. Pretty cool. Perimeter. Perimeter is going around the outside edge. Here is a new term to learn. Perimeter. It is the distance around the shape. Aunt Holly and Uncle Chaz need to know this more now because each of their fields is a different size. And they have to buy fencing to go around the outside edge. Perimeter is like putting a fence around an edge. I need to know how long each of the four sides are. Sometimes my fields are not perfect squares or rectangles, and one side is longer or shorter. But they connect and make perpendicular lines, and you go around the outside edge, and you put the fence around it. If each side of the square, A, B, C, and D, is 2 inches, 2 plus 2 plus 2 plus 2. Oh, hey, doubles. 2 and 2 are 4. 4 and 4 are 8. So I know there's 8 inches, and I would need 8 inches of candy or fencing. A fence out in Uncle Chaz and Aunt Holly's yard would be more like, could be 400 feet and 300 feet and 200 feet. It's a lot of fence to buy. If each says, so on my rectangle, if I have 2 inches and 8 inches and 2 inches and 8 inches, 8 plus 2 is 10. And the other side's going to be 10 too, so 10 plus 10 would be 20. I can also do a triangle. Triangle is 3 sides. If each side was equal, and pull and peels are about 8 inches. I would have 3 sides, 8 plus 8 plus 8, or 3 times 8. 8 plus 8 is 16, another 8 is 24. can make a triangle fence. The formula. So in math, a math sentence, sometimes if I do everything the same way, we call it a math formula. It's like a science term when I do math things the same way. The formula for perimeter is A, side A, B, C, D. So is A plus B plus C plus D equals perimeter. Now in a rectangle or a square, they're going to be equal sides, but it doesn't matter what the number is if it's not quite the same, because it makes a weird shape that's not a standard shape. I still just add the sides together. And what if it's a weird shape like a field would be, where it's here and here and here and here and here and here and here? I just add the sides together. So if I had a 7-sided field with 7 weird shapes that I had to go around, I would go A plus B plus C plus D plus E plus F and G. I could keep going. This rectangle is 5 inches long and 2 inches wide. So 2 plus 5 plus 2 plus 5 plus 2 plus 5 equals 14. Oh, here's a weird shape. And that could be like a field. It has 1, 2, 3, 4, 5, 6 sides. Then my formula would be A plus B plus C plus D plus E plus F. I can keep going. I just keep adding all the sides till I understand how much I need. Area. We measure a line by its length, but how do we measure the size of a shape? It is measured in square area. So I'll make a square again. When we look at area is more like putting a rug down on the floor. Perimeter, I want to build a fence. Area, I want to fill the whole thing in, like putting a carpet across the whole room of a house. How do we measure that? Well, if the square is 2 inches long, 2 segments, I can divide it that way. Let me get another pull and peel. I divided it in half and half. So if this, we'll say, is a group of 2, is 2 whatever, 2 whatever, 2 whatever, 2 whatever, 2 whatever. And I divided it. So now it's 1, 1, 1, and 1. I've made 4 of those groups. This one is 2 inches wide. So the formula is a multiplication number. It's the length times the width. If my segments are in 2 inches, or 2 feet, 2 times 2 is 4. I would need 4 of the pieces to fit in. What if it was 4 by 3? I could fit 12 of those pieces in. When I measure tile to fit on a bathroom floor, they're usually a 12-inch tile. So if my room was 4 feet by 3 feet, I would need 12 12-foot tiles to fill it all in. The formula for area is A times B. Grandma has to do a lot of math like that when she's building her quilts. To put the back on the quilt, I use area. To put the binding on, I use perimeter. Grandma does a lot of math. Oh, the triangle. Ooh. Now let's make another simple shape. My triangle's a little wonky because we've pulled these things apart and they're a little stretched out. But you get the idea. A triangle. The triangle is an equilateral triangle. Each of the angles are the same and each of the corners are the same. But there are other triangles. There is an isosceles triangle and a scalene triangle. A triangle with 2 equal sides is called an isosceles triangle. A triangle with no equal sides is called a scalene triangle. Another new word, vertex. What did one ray say to the other? Let's meet. We meet at where 2 rays meet is the vertex. So without the third side, here's my ray 1, here's my ray 2, and where they meet is the vertex. The point where the 2 rays meet is called the vertex. Circle. Now, the pull and peels don't make perfect circles. Because I've stretched them out of shape. But I can make a sort of circle. If you draw another simple shape, draw a point and put the curved line around the point. If the distance between the point and any point of the curved line is the same, then we call it a circle. Otherwise, it's an oval. The outside of the circle is called the circumference. The distance around the circle. Here are some more terms to learn about circles. The center, the radius, and the radius is from the center to the edge. That's the radius. And diameter is across the whole circle. So radius is from the center to one edge. The diameter is across the whole thing. And around the outside is the circumference. The short distance between the center and the circumference is called the radius. And using a straight line, the distance from one point on the circle through the center to another is the diameter. A line those 2 points that does not go through center is called a chord. So if I was measuring something over here, where's my other short piece of this? There it is. So if I wanted to measure this distance over here, that would be a chord. Degrees. We can divide a circle into 360 equal points. We call these points degrees. You can measure an angle by its degree. The size of an angle is measured by the degree between its rays. This is how you write a degree symbol. It's a little circle. It's a tiny circle that you put next to things. You can buy a special tool called a protractor. I don't think Grandma actually has one anymore. How do you know the size of an angle? You can measure it. The tool we use is called a protractor. Angles that are less than 90 degrees are acute angles, and ones that are bigger are obtuse angles. A cube. When studying geometry, we also learn about solid shapes that have 3 dimensions, length, width, and height. So like a box. A box is a rectangular prism because it's not square. But a square is a cube, like an ice cube. A sphere, like a ball, is a circle with shape. A pyramid is a triangle with shape. A cone, a pyramid has a square or rectangular bottom. A cone has a round bottom, like an ice cream cone. A prism has 3 sides instead of 4. But you can also make a rectangular prism, like a box. A cylinder, like a can, is 3-dimensional shapes. dimension. Do you remember the difference between lines, simple shapes and solid lines? A line, this is a line segment. It has one dimension. A rectangle has two dimensions. A side and a shape. And a rectangular prism would make a box. Twizzlers pull and peel math from simple shapes to geometry.